Hey guys, welcome back to lecture series on chi-square distribution, which is from the probability distribution, okay, which is your unit number 4th. Okay, so yesterday in my previous video, guys, I already explained to you all chi-square distribution, the formulas and the concept that we needed for solving the example. Okay, so if you are interested to see these videos, guys, go and check in my playlist. You will get these videos. Okay. So in my today's video, guys, I'm gonna explain to you all one of the very much important example based on the chi-square distribution. Okay, mostly I found this type of the example in your previous year question papers. Okay, yes. So without further ado, let's get dive into our today's lecture. First of all, we're going to understand example and then we go for the solution. Okay, so now see that in our example we do not have anything mentioned like apply chi-square distribution or anything else. Okay, that we how to identify, okay, what to apply. So using some terminologies or some abbreviation, you easily can identify what need to apply. Okay, so let's get dive into an example. First of all, I'm going to explain to you all the example what we have given. This example is mostly repeated in May 22, 21, 2018. Very important example for 5 marks. Maybe this time it's probable chances that you will get such examples. Okay, so here let me read the example. What we have given, the proportion of a blood type. Okay, so we have given blood type O, A, B and AB. So their proportion given, okay, in the general population of a country. Okay, the proportion of a blood type O, A, B, AB in the general population of a country known to be in the ratio 49, 38, 9 and 4. Okay, this is the ratio OAB and AB. Between these blood type, we have given the ratio for our population 49, 38, 9 and 4 respectively. Okay, a research team observed the frequencies. Okay, a research team observed the frequencies of the blood type as their frequency also given 88, 80, 22, 10. Okay, respectively in a community of the country. Okay, in a community of that country. So test hypothesis. Okay, so whenever you will get the wording like a test hypothesis, you need to understand we need to test hypothesis using chi-square distribution. Okay, that we learn in our previous lecture. Okay, what we learn when we apply chi-square distribution, whenever testing hypothesis. Okay, test independence of attributes, test goodness of a fit of a model. Okay, for that we apply chi-square distribution. So in our example, we have given test hypothesis at a 5% level of a significance that the proportions for this community are in the accordance with general population of the country. Okay, so we want we have to test the hypothesis at a 5% level of significance. Okay, so in the population ratio. Okay, so now see that you will get the chi-square distribution, chi-square value as a 7.815. Okay, that means you need to take this constant chi-square as a 7.815. Now we are going to test the distribution in our example. Now see that, guys, examples is not difficult, but you need to understand what to apply. Okay, and what to apply means you need to first of all extract data from our given data sets. Okay, so mostly what you do, make a table, inside table try to extract the data. Okay, so it is easier to understand, so try to extract the data inside the table. Okay, yes. So what we have given, now see that blood type. Okay, so whatever we have given, I'm trying to extract here as a given. Okay, so as you are going to write the extracted data only, you will get the marks. Okay, so I always recommend you all just to attempt the question. Okay, write down the given, make a table format, that you will get the marks. Okay, so what we have given, blood type first. Okay, yes, let me write the blood type. Blood type. So what are the blood types we have given? O, A, B and AB. Okay, O given, A given, B given. Okay, and AB it is also given. These many blood types are given. Okay, so I'm trying to extract the data from our given data sets, okay, in our data in our table format, okay. Yes, now see that after that we have given 49, 38, 9 and a 4, okay, as the expected frequency, okay. And after that we have frequencies of the blood type are 88, 80, 22 and 10. And now what we have given observed frequency of our OAB and AB blood type. Now see that observed frequency of the blood type 88, 80, 22, 10, okay. Now see that 88, 80, 22, 10, it is quite bigger number for our calculation. So as we are taking the ratio, so you can reduce these terms, okay. You can reduce this term, but make sure that all term need to reduce by same proportion or same ratio, okay. So that means you can reduce half here, half one here, half one here and half one here. So if you want, you can keep all these as it is, not an issue, you will get the required answer, okay. So but we as to saving time and strategy, this is time saving strategy that you can reduce. So see that we have ratio given, we cannot reduce because some even number, some odd numbers are there, so we cannot reduce here, but these are the all even number, okay. So we can reduce half by everywhere, okay, just to save calculation. So half reduction here we get the 40 for our first blood type, okay. Observed frequency for first blood type 88, so I'm taking as the half of this one. Again for A, take half of this one. For blood type A, we take 80, means it is going to be a 40. Again for blood type B, it is 22, that you can take the ratio as a half, and AB it is 22, that so with that we can take it as the 11, okay. What we have 10, it is the half as a 5, okay. So this one is our observed frequency, we denote it as the OI, okay. These are the observed frequency that we denote as a OI. So if you want to see what are the formula we are going to use, now you can see it here. This is the chi-square distribution. We are going to use observed frequency, expected frequency and expected frequency, okay, so that you will get the required chi-square distribution. Yes, now see that, so we got the observed frequency, okay. Now we want the expected frequency, okay. Expected frequency means EI, okay. Expected frequency, we want the expected frequency as EI, okay. This one is our expected frequency. Now see that what we have given in the population of a country are the known ratio, okay. So expected frequency ratio given, okay. So this one is the expected frequency observed for OAB, AB blood type, okay. But you cannot take the ratio or you cannot reduce this one because some numbers got different type of the combinations are there. For O we have 49, A 38, B 9 and AB it is a 4, okay. These are the expected frequency we have given, okay. So what we have 49, this one is the 49, next 38, afterwards 9 and at the end 4, okay. These are the blood type, observed frequency and expected frequency. This one is given for us, okay. Yes, now see that guys, we are going to apply our chi-square distribution to our data set, okay. This one is our given data set and we want the 5% level of significance, okay. Test the hypothesis at a 5% level of significance, okay. And for that we have given chi-square as 7.815, okay. Yes, so let's go, we go solve the example. So we know that the chi-square distribution can be found by summation I, which is equal to 1 to n OI minus EI bracket square upon EI, okay. So what is the chi-square distribution? Chi-square distribution summation of OI minus EI bracket square, okay, divided by EI, okay. So this is summation for this one also, I which is equal to 1 to k, I which is equal to 1 to k, okay. I which is equal to 1 to k. Okay, this is the formula that we are going to apply here. Now see that we want the OI minus EI for the 4 data set. Okay, that means O1 minus E1, O2 minus E2, O3 minus E3, and O4 minus E4. Okay, and we are adding all of them together. Okay, so let me find this separately, OI minus EI. Okay, OI minus EI, and take their square. Okay, so 44 minus OI means, observe, 44 minus 49. Okay, it is a like minus 5, and when you take minus 5 square you will get the 25. Okay, so what I'm doing here, I'm trying to get the all value for OI minus EI. Okay, first of all, and then at the end their summation means add all of these values. Okay, and add again EI and divide here, you will directly get the answer. Okay, so after this, next one, OI minus EI in then bracket square, 40 minus 38, 2 bracket square, we get the 4. Okay, next 11 minus 9, it is a 3. Okay, and a 3 square, it become 9 again. Okay, first 25, 4, and 11 minus 9. Okay, so 11 minus 9, how it will be? It is 2, sorry, it is 2 guys, not a 3. Okay, so we write it as a 2 square is a 4. Okay, 11 minus 9. Okay, 9, 10, 11, 2 square is a 4. Okay, their square, OI minus EI square, OI minus EI bracket square. Okay, 5 minus 4, 5 minus 4, 1 bracket square, again 1. Okay, so we got these many values for OI minus EI. This one is our OI minus EI bracket square. Okay, yes. Now what we are going to do, we want the summation for all OI minus EI from our data set. Okay, that means 25 plus 4 plus 4 plus 1. Okay, 25 plus 4 plus 4 plus 1, and divided by EI. Okay, that means 25 by 49 plus 4 by 38 plus 4 by 9 plus 1 by 4. Okay, yes. So let me write chi-square. How can we write? Okay, O1 minus E1 bracket square divided by E1 plus O2 minus E2 bracket square, okay, divided by E2 plus O3 minus E3 bracket square divided by E3 plus O4 minus E4 bracket square divided by E4. Okay, these are the chi-square distribution. What I am doing here, guys, I am trying to expand this chi-square distribution. Okay, with respect to our data set. What we have given, 1, 2, 3, 4 type of the data sets we got it here for OAB, AB. Okay, so let's put the value OI minus EI, O1 minus E1. This one is O1 minus E1, O2 minus E2, O3 minus E3, and O4 minus E4. Okay, so O1 minus E1 bracket square is a 25 divided by E1. What is the E1 here? 49. 25 by 49. Okay, plus O2 minus E2 bracket square, it is a 4 divided by E2. What is the E2 we have here? 9. 4 by 9 plus O3 minus E3. Okay, 4. O3 minus E3 is a 4. Okay, 4 divided by E3. Okay, sorry, 4 by 38 here. So 25, 49, 4 by 38 plus 4 by 9 plus 1 by 4. Okay, 4 by 9 plus 1 by 4. I hope you all have understood how I have written, guys. It's not that difficult. Okay, it is one of the easy. Or simply you can, what you can do, first of all write down observed frequency, expected frequency, and find out OI minus EI square. Okay, then at the end what you need to do, you want the chi-square distribution, chi-square distribution. So this divided by this plus this divided by this plus this divided by this plus this one divided by this one. Okay, this is the your required chi-square distribution. Okay, so if you're going to add this chi-square distribution, okay, chi-square distribution, you will get the value 1.309. You can use the calci, guys. Okay, this one is allowed for your exam. Okay, chi-square, we got the distribution 1.309. But in our given example, we have given chi-square distribution. What is the chi-square distribution? 7.815. Okay, this one is our chi-square distribution given, okay, in our example. And in our example, what we have given chi-square distribution. Okay, is a 7.815. okay, this one is a chi-square distribution given as 7.815. okay, so you just have to compare both of them that we received from here. okay, so this is our required answer that you can solve it up to here. So if you want, you can define how their relations is here. okay, yeah, this one is our answer that we found from our example, and given in our chi-square it is 7.815. okay, so the hypothesis which we received here, which is smaller than our chi-square distribution. okay, this one is smaller than this chi-square distribution, so that we can accept. okay, then we accept it. So we are going to accept this one. okay, so I hope you all have understood, guys, my today's lecture. It's not that difficult. It's one of the important example, guys, that we learn here in our today's lecture. So I hope you all have understood everything. So for your understanding, if you wanted to note it down this solution, you can pause the video, note it down the example and its solution. okay, so here it is our required answer. okay, I hope you all have understood, guys, everything here in my today's lecture. Even after, if you found anything difficult, confusing, let me know in my comment section, guys. okay, I will come up with a similar videos. okay, so this one is a chi-square distribution important example. So we go for more important example in our channel, guys. okay, in our subsequent lecture series. I hope you all have understood everything here in my today's lecture. So thank you everyone. Thank you for my today's lecture.